Module 2, lesson, or topic 2, lesson 2. Been there, done that, got the T-shirt. So let's look at this. It says, does this show proportionality? Okay, so remember, it is the change in y over the change in x. So 6 over 8. That simplifies to 3 over 4, which is 0.75. 7.5 divided by 10, look at that. That goes down to 0.75. 12 over 9, oh, I did not just do that. 9 over 12. 3 goes into both of those, so that gets me 3/4, which is 0.75. So my constant of proportionality is 0.75 or 3/4. Okay, consider the linear models you created in the previous lesson. Okay, you wrote a linear equation, y equals mx plus b, created the tables of values to represent the relationships between the independent and dependent variables. Graph the points as a straight line on a coordinate plane. Okay, so US shirts, it was $8 per shirt plus sign, $15 setup fee. So right there. Okay. Hot shirts, we had $5.50, and then we added a one-time fee of $49.95. Okay. How can you tell from each situation that the relationship is linear? Okay. There is a slope that doesn't change. It is non-proportional because they each have a setup fee. How many points do you need to draw a straight line? Well, in reality, you need 2 points. But to make sure you did it correctly, it is better to do 3. What does the structure of the equation tell you about the graphs? Okay, so we have y equals mx plus b form, right? So it tells you that it's linear. It tells you it has a slope. It tells you it has a y-intercept other than 0, 0. How can you tell from the table that the relationship is linear? Okay, so we haven't really talked about it, but we could find this goes up by 8, this one up by 1, this one up by 16, this one up by 2. The change in y over the change in x comes out to 8. This one, seriously? Okay, if I have 55 minus 39, that is also 16. This is also 2. Still going up by the same amount. That's 40. That's 5. 40 over 5 is still 8. So it's linear. Okay, Here, 55, 45 minus 49.95. Ugh. Sometimes I really wish I would use a normal calculator. Minus 49.95. Oh, that would get me 550. This would get me 1, so that works. Then if I have 66, oh, that's 11. That's 2. 11 over 2 gets me 5.5. This next one, oh, that's 11 again. That's still 2, so that's 5.5. Then 104.95 minus 77.45. This is 27. Did I do that right? That is not right. 104.95 minus 77.45. Oh, I guess it is. Oh, then this is 5. If I was to divide 27.5 by 5, I would get 5.5. That's how I can tell. So, the scenario of U.S. shirts tells you that the cost of one T-shirt is $8 per shirt. You can represent the rate of change as a ratio of the vertical distance to the horizontal slope on the graph. Okay, we've talked about this. The change in y over the change in x. The vertical over the horizontal change. Okay, now we can also do it from a table. And that's what I was just doing a moment ago. Okay, what does 0.15 mean? When there are 0 shirts, the setup fee is $15. $15. Okay, what does this mean? One T-shirt will cost $23. That's what it means. Use the right triangle to verify the slope on the line. So if I do a right triangle, I go from here to here. So this is 15, and it's going up to 55. 55 minus 15 will get me 40, so that's 40 tall. Come on. And that goes over 5 times. So 40 over 5 gets me 8. Okay, so 40 over 5 gets me 8. Okay. So, what we're going to do now is you can calculate the slope of a linear relationship from the table values by doing some subtraction. So, I'm going to show it to you up here, some subtraction. So if I was to subtract my y values, so 23 minus 15, that's going to get me 8. If I do this one, 39 minus 23, that's going to get me 16. 55 minus 39 is going to get me 16. Okay, over here, 1 minus 0 is going to get me 1. 3 minus 1 is going to get me 2. 5 minus 3 is going to get me 2. So, I'm doing the change in y over the change in x. So if I look at the top one, I would get 8 over 1, which is 8. The next one, I would get 16 over 2, which is 8. 16 over 2, which is 8. So what did I do? I subtracted these two over subtracting these two. So let's come down here. So that's what this is talking about. If I take these 2 points right here, I'm going to subtract my y values. So remember, this is my x, this is my y, this is my x, this is my y. So I'm going to take the 23 and I'm going to subtract the 15. Why didn't I do it the other way around? Because I would end up with negative numbers. Okay, and so since I used the 23 first, that means I have to use the 1 first. So 1 minus 0. So when I subtract that, I get 8 over 1, which is 8. Okay, so we're going to do that with 123 and what was the next one? 339. So we really already did it, but we're going to look at it like this. Okay, so I'm going to find my slope by subtracting my y values and subtracting my x values. I'm going to change the colors. So this is a y value and this is a y value. I want to do 39 first and then 23. Why did I do the 39 minus the 23? So that it would come out to be positive. Then I'm going to take the x values and I'm going to subtract those. Since I started with 39, I need to start with 3 minus 1. Notice, boys and girls, these two come from the same point. And then these two, they come from the same point. Okay, so they have to line up nicely. Okay, so when I do this, I'm going to get 16 over 2, which is 8. Then, if I was to do 339 and 5, I can't remember what it is, 555. Okay, so again, I'm going to subtract, and I'm going to take my y values. These are my y values, and I'm going to subtract them. And then I'm going to take my x values, and I'm going to subtract those. And I'm going to do 5 first, and then the 3. Again, these two came from the same. These two came from the same point. So m equals, this would be 16 over 2, which is 8. Analyze the calculation. I use the ratio y over x to calculate the slope of the line. Okay, so it's supposed to be the change in y over the change in x. It's not the actual y value over the x value. That only works when it's proportional. This is not proportional. This is non-proportional. Okay? So you have to do the change in y over the change in x. So you have to subtract the y values and subtract the x values. How is the strategy of the slope formula given in the table of values related to using similar triangles on the graph? Oh, the change in y is the height. So you subtract y's. The change in x is the base. So you subtract, loved how I forget that, x's. Ron has a player's card for the arcade that keeps track of the number of credits he earns as he wins games. Each winning game earns the same amount of credits, and he already has points saved on his card. Examine each example. Follow the arrows to calculate the slope. Does each example correctly calculate the slope? Okay, so this first one, it says for the y values, 440 minus 120. See how the arrow went this way? So then this one goes from 40 to 0. So when I do that, I get 320 over 40. So that gets me 8. Okay, I'm going to pick a different color. So this next one tells me for the y values to do 320. See how the arrow goes this way? Minus 440. And then this one goes this way. So it says to do 40 minus 25. So if I subtract that, that's going to get me negative 120 over, that's a 515. Oh, automatically it's not going to be the same because doesn't that have a negative sign? So negative 8, is that right? I know. So 120 divided by 15. Yeah, negative 8. So last but certainly not least, I'm going to do this one. And it tells me that I'm going to start at 216. And I'm going to subtract 264. And then on the bottom, I'm going to go from 12 to 18. So 216 minus 264 is going to get me negative 48. And 12, and that's a negative 6, but that comes out to 8. Okay, see how these are exactly the same? Look at the arrows on each one of these. These arrows both went this direction. Both of them went the same direction. This one, they both went the same direction. But here's the problem. These two went totally opposite. These are wrong. You have to go the same direction in order for it to work. Okay, so we're going to calculate these. Okay, so we're going to calculate these. So we're going to subtract here, subtract here. So my slope is, oh, I guess I'm supposed to show the arrows the other way. This way, whatever. 12 minus 9 over 8 minus 4. So that gets me 3, is that right? 3 over 4. Could I have done a different one? I could have done a different one. Could I have used these two right here? I could have. I could have done 30 minus 12 over 32 minus 8. When I do that, that's going to get me 18 over 24. 6 goes into both of those. That gets me 3/4. So it didn't matter which one I did. Okay, so let's try this one. Oh, I don't know. Here to here, here to here. So if I do that, I go from 25 to 21. I go from 7 to 9. When I do that, I get a 4 on top, and I get a negative 2 on bottom. So my slope is negative 2. Okay. Next, this one. I'm going to pick red again. I don't care. We can go from here to here if we want. And so that means I have to go from here to here. So my slope is negative, or not negative, 13 minus a negative 152 over negative 1 minus 10. So if I do that, that turns to a plus sign. So that gets me 165 over negative 11. So m equals negative 15. Now on that one, could I have picked different numbers? Sure. Could I have gone this direction? I could have done this direction. I like those zeros. Those zeros are awesome. So negative 62 minus a negative 2. 4 minus 0. That turns to a plus. Negative 64 over 4. Oh, look at that. So that still gets a negative. Did I do that right? No, that's 60. I knew I did something wrong. And then this one, let's look at this. From here to here, here to here. 9 minus 9 over 7 minus 18. So my slope is 0 over negative 11. Oh, look at that. 0. Look at that. All the y values are 0. Okay. Which relationships in question 1 are proportional relationships? I don't know. Let's look. This first one, if I did 9 over 4, does that equal 3/4? Nope. So that's not it. 25 over 7, does that equal negative 2? Nope, that's not it. This has 0, negative 2. That's not it. I don't know. None of them. Unless I did something wrong. And maybe I did. Did I do any of those wrong? 2. No, I didn't. Okay, complete the sentences to describe how you can tell whether the slope of the line is positive or negative by analyzing points. When the slope of the line is positive, the value of, okay, so x is increasing. So let's look at this one that was positive. This one was positive right here. So as the x got bigger, what did the y's do? Look at the y values. What did they do? They also got bigger. So they increased also. Okay. When the slope of the line is negative, the x increases as the y value does what? So this one had a negative slope. X got bigger. What did y do? Look at that. They got smaller. Okay, so they decrease. Okay, so let's look at this. Sketch the graph of the relationship. Okay, so if I sketch this first one, I have 1, negative 5. 1, 2, 3, 4, 5. It's right here. 110. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right there. Look at that. It's going to be a vertical line. Let's look at this one. 5, 1, 2, 3, 4, 5, 2. Then 6, 2, 7, 2, 8, 2. Look at that. That's going to be a horizontal line. Okay, so when x equals a number, you have an undefined slope, and it's a vertical line. When y equals a number, you are going to have a 0 slope, and you are going to have a horizontal line. Okay. Now we have to tell whether it's linear or not. Okay, so in order for something to be linear, the slope has to be the same. Okay? It has to be constant. The slope, oops, sorry, did not mean to do that. I meant to highlight. The slope is the same between any 2 points on the given line. The converse is also true. I didn't like the fact that that was. If the slope between every ordered pair is the same, it's constant, then it'll form a straight line. So now we have to check and make sure on this right here if the slope is the same. Okay? So I'm going to go from here to here and from here to here. Okay? So 28 minus 13 over 9 minus 5. Okay, so that'll get me 15 over 4. So then I'm going to come to this next one. And I'm going to go from here to here and here to here. So 34 minus 28 over 11 minus 9. Okay, 34, oopsie daisy. That's going to be a 6. That's going to be a 2. That gives me 3. Did I subtract correctly over here? 15. Oh, 9 minus 4. That gets me a 5. So that would be 3. Sorry about that. Then I do the same thing here. So my slope is going to be 47 minus 34 over 16 minus 11. So that's going to get me a 3, a 13. Is that right? Since I'm doing so well with my arithmetic today. And that's a 5. Oh, nope. Got to make sure that I'm doing it correctly. 47 minus 34, 13, 16 minus 11, 5. Yeah, so is it a linear relationship? No, because the slope is not constant. Oops. Constant. Okay, so let's look at this. When the values for the independent variable in the table are consecutive integers, that means 1, 2, 3, 4, 5. It goes right in a row. You can examine only the column with the dependent variable. So if you just look at the y values, okay, if I subtract just the y values, you would have noticed that it came out to negative 13 each time. Okay? This is called first differences when you have them going right in a row. So let's look at this. Okay, these are first differences. So all I'm going to do is I'm going to subtract 34 minus 25. When I do that, I get 9. I'm going to subtract these. 45 minus 34. I get 11. Right here, 52 minus 45. 7. Sorry. Oh, sorry. Whew. Okay, and then this would be 9. So do you notice how these numbers are not the same? They are not consistent. Okay? So this is not a linear relationship. Okay? So let's look over here. Okay? Maybe I'll change the color. If you look at all of these, they go up by ones. So I'm going to subtract here. That would get me negative 4. Subtract here, negative 4. Subtract here, negative 4. Subtract here, negative 4. So yes, it is a linear relationship. Okay. Let's look at this one. Again, it goes by ones. So from here to here, that would be 3. From here to here, that's 5. So no. And then we look at this last one. Again, these are firsts. So I subtract here. That gets me 3, gets me 3, gets me 3, gets me 3. So yes. So on the two that are yes, so the slope for this one would have been -4, and the slope for this one would have been 3. Okay. I'm going to switch to, I don't know, green. Understanding the y-intercept. The slope is one important characteristic of a linear equation. Another important characteristic is the y-intercept. The y-intercept is the y-coordinate, we've talked about this, the y-coordinate of the point where the graph crosses the y-axis. It is the value of the dependent quantity when the independent quantity is 0. It looks like this. Now, a lot of times people, oh, goodness gracious, really? I like to say it's like this, but 0y is correct. Justine drains the water from her 300-gallon fish tank to clean it. Her pump drains the water at a rate of 4 gallons per minute. Write an equation in the y equals mx plus b representing the relationship between the number of gallons of water in the pond and the time in minutes. Okay, so remember, when we're dealing with slope always has a per in it, or a 4, or out of every. So this right here, it even tells you that it's the rate. So that's my slope. So my slope is 4 gallons. Okay? Now, you have to be careful in this because you have to decide whether it's going to be positive or negative. Oops, I should have put gallons per minute. Now, you have to be careful. What does this actually say? Doesn't it say it drains? So isn't something getting less and less and less? So that's actually a negative 4 gallons per minute. Okay, it gets less. Okay, then what did we start with? How many gallons are in that fish pond? How many gallons did we start with? We started with this. So at 0, we have 300 gallons. So let's write this. My slope is -4x. My y-intercept is 300. Okay. What does the b value stand for? What does my y-intercept stand for? 300 gallons, of water in the pond. That's what it stands for. Okay, and I always have you write it as an ordered pair. How does the b value relate to the, it's the same. Okay, for each linear relationship, determine the y-intercept, write it as an ordered pair, and explain what it means. Okay, so Una has 412 pictures saved on her phone. She accepts a challenge to take 3 photos with her phone each day. Okay, so let's look at this. Do you see how it says each day? It says 3 photos each day. That's going to be our slope. Okay, that's going to be our slope. This is what she already has this on her phone. That's where we're starting at. So 0, 4, 12 is what our y-intercept is. Okay, what does that mean? She starts with 412 photos. Oh, I love how I put there we go. That's what she's starting with. So let's look at over here. Ralph uses a cardboard box that weighs a half a kilo to mail a shipment of handmade mugs to a store. Each mug Ralph uses a cardboard box that weighs... Okay, so he's got to use the cardboard box, okay? And depending on this right here, each mug, that's going to give me my slope. This right here, the box, you've got to mail the box. No matter what. This right here, you've got to have that half a kilo. So that is going to be my y-intercept. The box weighs, starting out, a half a kilo. Then once you start putting mugs in it, then it gets heavier and heavier. Okay, for the graph, determine the y-intercept. So where does it hit the y-axis? So it hits right here. Well, this is 5, that's 10, this is 15. So that means 0, 15. Well, let's look at this. It says total cost is the y, number of shirts. So that means my setup fee is $15. Over here, it just wants the y-intercept, right? Yeah. Over here, it's halfway between 4 and 5. So this point right here is the point 0, 4.5. And this says the water level. Okay? This says time. So that means at 0 time, or 0 seconds, the water level is 4.5 feet. Then this one, right here. Well, what's this going up by? This is 2, 4, 6. So it's going up by 2s. So this is -8. So down one more would be -10. So distance from the park. So it says time since noon. Well, at 0 minutes, that means at noon. They're -10 blocks from the park. That makes absolutely no sense whatsoever. What does that mean? You're in the park? That makes no sense at all. Uh-oh. It doesn't show what this one is. I have no idea. Well, let's see. What's my slope on that? I don't know. I don't know what my slope is. So if I have that this right here is the point 60 and it's at 40 and this was at 85 and oh, I don't want to do that one because that's going to give me a decimal one, so I don't want to do that one. Let's see. This one? That's at 80, 15. So every 20 for the x, so every 20 for the x Oh, that was a horrible line. Every 20 for the x, it goes up 25. Goes up 25. Yeah. So that means that at the point 40, it's going to go when x is 40, that means the y is going up by 25, so that would be 65. And at 20, it goes up by 25 more, so that's 90. And 20, oh, that gets me to 0, so I add 25 to that, so 115. So at 0 minutes, you are 115 miles from home. Okay. So, being able to find the y-intercept. We're not going to follow their way as to how to find the y-intercept. We're going to use this right here. Okay? We're going to find the slope. So first, you're going to find the slope. Oh, I guess we didn't have to take out all of that. First, we're going to find the slope. And then second, we're going to use the slope and 1 point. Okay? So, we're going to find the slope. They found the slope to be 3. Then they're going to use this point right here. So we're going to plug it into y equals mx plus b. So the y value is 13, the m value is 3, and the x value is 4. So I'm going to plug it in. 13 equals 3 times 4 plus b. So 13 equals 12 plus b. I subtract the 12 and I get 1 is equal to b. So my y-intercept is 0, 1. Okay? So I'm going to use a different point. I'm going to use 310. Okay? And we already know our slope is 3. So I'm going to take y equals mx plus b. Remember, this is my x value, this is my y value. So 10 equals, my m value is 3, my x value is 3, my b value. So 10 equals 9 plus b. I subtract 9 from both sides and I get 1 equals b. Same thing. I'm going to use my last one. 27. So I'm going to use 27, and the slope is equal to 3. So y equals mx plus b. Remember, this is my x value, that's my y value. So 7 equals 3, 2 plus b. So 7 equals 6 plus b. Subtract 6 from both sides and get 1 is equal to b. So every single time I came up with 1 being my y-intercept. Okay, so we're going to do the y-intercept for here. So I'm going to subtract this way, and that gets me 2. I'm going to subtract this way, and that gives me 25. So 2 over 25 is my slope. Okay, and then I don't care which point. I like this one because it's, oh, I could use this one right here. So that's my slope, and I'm going to use 200, 14. So remember, this is my x, this is my y. Y equals mx plus b. So I take 14 equals My slope is 2 over 25. Multiply that by 200 plus b. Okay, 25 goes into 200 8 times. So 14 equals 16 plus b. Subtract 16. Get negative 2 equals b. So 0, negative 2. Okay. This one. If I subtract here, I get 1. If I subtract here, I get 3. So my slope here is 1/3. I don't care which one we use. I'm going to use this one, right? Do I want to use that one? Not really, but I'm going to anyway. 25/93. So this is my x, this is my y. So 93 equals 1/3 times 25 plus b. Oh no, this is going to be a fraction. I don't like fractions. Fractions are my enemies. Okay, so guys, we want to get rid of that fraction. So I'm going to multiply both sides of my equal sign by 3. That's going to get me a 9. That's going to get me 279. 25 plus 3b. I subtract 25 from both sides. It's going to get me a 4. That's going to get 5. This is going to get me 3b. Divide by 3. 3 goes into 25 8 times. Oh, that's going to be an ugly number, isn't it? 254 divided by 3. Yeah, so we just leave it as that. So my b value is 254 over 3 is equal to b. So 0, 254 over 3. 93 times 3. I just want to make sure I use the right numbers. 254. Yep. Okay. Okay, we're going to do the same thing here. We're going to find the slope. So, how tall is it? And how far over is it? Okay, so how tall? We go from 10 to 30. So that's 20 tall. We go over from 60 to 70. So that's 10. So my slope is 20 over 10, which that means my slope is 2. And I'm just going to pick this point right here. Y, who knows? 70 comma 10. So y equals mx plus b. My y value is 10. My m value is 2. 70 is my b, or my x value. So 10 equals 140 plus b. Oh, no. Stop. Stop the presses. That is a negative slope. This would be a negative slope, a negative slope. Bad, Miss Grambois, bad. So 150 is equal to b. So 0, 150. Then this one, this is a positive slope. How tall and how far over? So it goes from 3 to 9, so that's 6 tall. It goes from 5 to 10, so that's 5 tall. Oh, okay. 1, 2, 3, 4, 5, 6, yep. So my slope is 6 over 5. I'm just going to use this point right here, so that's the point 5, 3. So y equals mx plus b. The y value is 3. The m value is 6 over 5. That's a 5 plus b. So these 5's cancel, so 3 equals 6 plus b. Subtract 6 from both sides and get negative 3 is equal to b. So the y-intercept is 0, negative 3. Okay. And last but certainly not least, walk the walk. Calculate the slope between each set of ordered pairs. So from here to here, that would be 70. From here to here, that would be a 424. Is that right? Yeah. So that's 70 over 24, which is 35 over 12. Well, that's interesting. So if I subtract these, 300 minus 120 is going to get 180. And this, oh my gosh, seriously? 300 minus 120, 180. I got that. 110 minus 40 gets me 70. So 180 over 70 would get 18 over 7. I think I did something wrong. Seriously? That was 24. 120 minus 50. It is 70. 70 divided by 24. And 18 divided by 7. No, they're not the same. Interesting. Oh, is it linear? No. What does this mean in terms of the problem situation? You can't find the equation. Okay. Given the graph represents the ordered pairs from the table, show how to use the graph to verify the slope you calculated. Okay. So we went from 120, that's 70, and we went from 16, that's 24. I don't think I did it right. 35 divided by 12 gives me 2.9166 going on forever and ever, divided by 7. 300 minus 50. 250. 110 minus 16. 94. 250 divided by 94. Yeah. Show how to use the graph to verify the slope you calculated. That doesn't make any sense whatsoever.